In our today's class, we will first recap a little bit about function overloading, and then we will show you an example of function overriding. In short, function overloading is one of the most powerful features for code readability and usability. In function overloading, okay, what we do, we actually make various functions within a class that differ from each other in function signature. So what is a function signature? It is the order of the parameters, the different parameter types, or the number of parameters, or how they are arranged. So two function with the same name but different number of function signature. And what is a function signature? It's various functions shared the same name with different parameter types or number of parameters. So as an example, we were practicing the add class, where we can add two classes. So in this add two classes, what we can do, so this is add, this both are add function, but in the first one we have two integer variables, integer x and integer y, and in the second one we have float x and float y. So in our program, whenever we give input to integers, the first function will called, and when we give to float, the second function will be called. If we give one float, one integer, none of this function will be called. So a function in C++ is not uniquely identified by its name alone. So in C programming, we could identify a function by only with its name, because for a name, only one function was allowed. But in C++, for the same name, we can have multiple function. And there's another name we use function is we also sometimes call them method. Okay, so together, by combining with function signature and function name, we can actually identify a function. Now, for example, for function overloading, what is the official definition is the process of providing more than one functions with the same name is called method overloading or function overloading. So you will have one function, but the function will have multiple definition, or there will be multiple function with the same name, and we call these functions overloaded function. The overloadings make sure that we can provide a consistent or clear interface to our methods, okay, regardless of the parameter type. So whenever the user gives two input, okay, the function will automatically decide which function to call. The program will automatically decide which function to call. It's like adding two numbers. So whenever you are adding something in your calculator, just think that whenever you add an integer and a float, or an integer or another integer, or a float and float, you don't have to select a different types of plus sign for that. Okay, there is only one plus sign in your calculator. Every time you do a calculation, you just press that plus, it automatically defines that what type of operation it is doing. So this is basically what giving the same. To understand the importance of function overloading, let's just think about a calculator. Okay, so let me show you a picture. So look at this image. In all the calculators that we use, we only have one plus sign. You see, one plus sign. So by using this one plus sign, we can add two numbers, that is integer, or we can add multiple numbers. Okay, we can add one integer, one float. So instead of just think that norm, instead of having one plus sign, you could have had five plus sign. One for adding two integer, another plus sign for adding two float, another plus sign for adding three float. So how this overall calculator will look like? For a simple plus, you had to have five button. For multiplication, you have to have five button, but we only have one, right? So one button does the job for all the other buttons. So same way, okay, in the back end of the program, or in the hidden behind from the interface, we also have this different functions which actually decide that, okay, so whenever we're doing the calculation, close this one. So whenever we're doing the calculation, they automatically calls the appropriate function. They understand, okay, this is the input, so I need to call this function. Now, enough talk about function overloading. So now let's go see. The compiler works out with the methods to call the based on the parameter it is passed. So in this one, compiler actually, whenever you give an input, compiler decide, okay, so I have this input and I have these three functions. Okay, so let's take this work to this function. It will check for the method that has a matching signature, and we know what is a signature. It is order of the parameters, number of parameters, the type of variables of the parameter. It will execute the method only. Okay, if no matching signatures are found, a compile term error will be displayed. So for example, normally whenever we call a function, okay, if it matches, that part of the program will be executed. If it doesn't match, okay, it will show us an error. Now, this is one example. You see, add two numbers. So this is the first case. We're adding two numbers, integer, integer. So we return the summation. Add numbers, float, float. We return the float. And this is, what is this? Seal. This is a function that actually takes the upper value. So like when you have 3.57, it makes it 4. When you have 3.7, it makes it 4. Okay. Now, in the main program, you see that we are calling the function add number, add number, add number. So first two will work fine because we have given the definition of integer, integer, and float, float. But the third one, you see, third one will not work because this one is a float number and this is an integer number. And there is no definition in all this function for integer and float. So in this way, function overloading work. Now, let's go to the one main topic, that is function overriding. So in case of function overriding, okay, the first thing is that when we use the function overriding is during the inheritance. So whenever we inherit one class from another class, okay, sometimes it might happen, okay, that two function might have the same class. So first thing, that we use the function overriding in case of inheritance. Okay, can we use it outside of inheritance? Yes, there are some cases where you use it, but most cases our focus is in inheritance. So when we are using the inheritance, we use function overriding. A function in a child class overrides a function in the parent class. Classes in which functions are defined must be in a parent-child relationship. Overloading deals with multiple functions in the same class with the same name but different signature. So without going to the definition, let's go to the example. So let me go to the code blocks and show you the example. So here, can you see the code blocks? Okay, now, so first of all, let's start with a simple program that we practiced in the last class. So in this program, let me take, I'm not sure whether it was that one. But let me open the program. Let's see. No, not this one. Yeah. So let's start with the program that we have two classes. One is called animal class, and we from that animal class we have derived the dog class. And one thing I have said in the last class, that what is easy relationship, that whenever two classes have an easy relationship between them, that is a relationship. Okay, only then we can use this type of inheritance. So in this case, dog is an animal, so that means we can use a inheritance. Now, so first thing first, let's remove this one. Okay, now, whenever we know that whenever we inherit a class, we get everything from this program or from this class. So now, okay, if I, okay, let me erase this one. Okay, if I write nothing, just derive the class, okay, dog, animal. And from this one, if I just call this two function, dog.sleep and dog.eat, okay, it will run this two program. So let me share the screen. So I'm running the program. Yes, you see, from the parent class, I can eat, I can sleep. So it's calling this two functions. Now, one thing is that if I write down the name of the function, obviously it will call the function, right? So I'm writing eat, I am writing sleep, so it's calling the function. The answer is that it's not that simple. So first of all, it can only, this is the object of doc class. Okay, we know that one object of one class cannot call the function object of another class. For example, to prove that, okay, what we can do, we can just write this one for now, and we have created another class. So to make clear about this one, so let's make it bird. Okay, and it will not inherit any class for now. So now, if for this bird class, okay, it will not inherit anything. This is just a class, and what we'll try to do, we'll try to create an object of the bird class, bird one. Now we have seen the dog1.sleep, dog1.eat, and dog1.sleep. If we run the program, they are being called, and we can see the output. Same way, let's try to call the bird1 dot, oh sorry, yeah, bird1.eat. So this is the object. Now, if you see, if I try to call this bird1 dot eat, the program will show us an error. So let's see what is the error. Okay, just a minute. Okay, for some reason mouse is not working in this case. Let me just scroll here. Hmm. Here, the bird class has no member named it. That means the bird class here has no member, but same way we can see the dog class doesn't also have any member. Okay, let's remove this one. So what is the difference between this bird class and the dog class? The only difference is in the dog class we're inheriting the public. So that means all this code that we have in the animal class, they're being copied here. I have told this in the previous classes as well. But in the bird class, okay, we didn't inherit, so that's why it's showing the error. So but this program will not run. Okay, now if I just change it a little bit, okay, if I just change it, then okay, let's make it public animal. Now we'll see, okay, that, okay, sorry, not this one. So if we just write this and try to run the program, now you see it's getting called. That means inheritance is important, and also it's important that we create the proper classes. Okay, now this is the first thing, that even if both of them have nothing written here, only by inheriting a class it can call the functions of that class. Number one. Number two, so sometimes what we need to modify the class a little bit. Okay, so in this one, that's where our bar class comes in. So we have inherited the dog class and we have added something more, the main reason of inheritance. So if we now run the program again, you see output is I can eat, I can sleep, and I can work. It's from derived class. So that means we can add something, but we are not, we know that how inheritance work. Our topic is, what if I want to change it? Okay, what if I don't want to write that I can eat? What if I want to change it and I want to write, you know, uh, I want to write that, no, I don't want to write derived. Okay, let's change it. Okay, I want to write, I am Mr. Dog class. So I want to change what's here. In that case, okay, what we do, if I run the program, you'll see that the line that was being printed so far, parent I can eat, is not here anymore. So this is the first concept of overriding. So whenever we have same class, you see the class void it in the parent and in the child. So in the parent we have the void it class, and in the child void it class. So when we have the same classes in the parent and child, we don't call the parent class anymore. So let's forget about this one. Just by writing the definition here, forget everything else. If I just write this void it, nothing else, okay, you'll see that it will not print anything anymore. See, I can it is not here anymore. So just by writing the name of the function in the child class, what we do, we replace the parent class. So if I just write here again void sleep, and if I don't write anything, the same way you will see the parent class is not getting called anymore. You see, I am sleep is also vanished. So if I just remove this, if I just remove this too, and if I run the program, now it's okay. So what is our lesson? That overriding means that whenever the parent class and the child class have same name of a function, the child class replaces the parent class. Number one. Number two, that if you still if you still want to call the parent class, okay, that, okay sir, I want to change this a little bit. Okay, I like this, that I void I can eat. Okay, so here instead of writing this, I want to write I am dog class, and then I want to write I can eat. So I want to do both. So there are two ways you can do this. One is that you can write two console output here. Then you can just copy this console output here. So this is one way. Okay, so if I now run the program, you'll see I am dog class and I can eat. But In C++, we are looking for efficiency. This line is already here. Okay, this line is already written here. So is there any way we can do this? What if we call the it class here? Like, mm, what if we try to call the it class here? Will it work? Like animal.it, as the name of the class is animal. Let's see whether it works or not. You see, it's not working because you cannot directly reference a class here. Okay, so this is a unqualified ID because this is a class name. You need to have an object to call the functions. Okay, some of you made the mistake here. So what we can do, let's see. What if we write this? Is it work? No, it doesn't work as well. So the thing is that if we want to call the parent class, okay, we need to have an object, and here we don't have any objects, so we are unable to call the parent class. Number one. Number two is that if you write everything here void it, okay, the same name as the parent class, the function will be replaced, and this is the idea of function overriding. Now, why we use overriding? Sometimes what we need to do, we need to take the parent class, but we need to change the parent class, and in that case we use function overriding. So let's go to another example. So this is a function called base class. Okay, and this is a derived class. The name of the class is also derived class. So in the base class we have, or the parent class, we have a function called display that represents function of a parent class, and in the base class we have a function of the child class. So if we just run the program, you see what happened. The function of the child class is called. Okay, and in this example you'll see this is a little bit different. Okay, so if I run this program, the function of the parent class is called. So now I will explain you how these two programs work. So let's start with the first one. So here everything is same, just the example that I have shown you, the dog class, it class, and bark. Okay, so everything is same here as well. We have only one function, that is display function. Here we also have one function, that is display function. So function of a child class, and display function in parent prints function of a parent class. So this is parent, this is child. Now what we are doing here, we are creating an object of the derived class. Okay, and the name of the object is obj. Now after creating the object, we are calling the display function. So as this is an object of the derived class, whenever we write object.display, it calls the function of the derived class, and in our case this is the derived class. Again, as whenever we are creating the object, this line is creating an object that is called obj, unless limit x, or x, yes. So this function, this line is creating an object of name x, and when we call x.display, it calls this display class. Now, and in the second example, the difference is that here, whenever we are creating the object, we are creating the object of the base class. Okay, but we are keeping the reference of the child class. Now look closely what happens here. If I run the program, it's printing function of the parent class instead of function of the child class. So what is the difference between these two code? This line of code, you see base class x, derived class x, derived class. So the difference is only this one. In the first example, both were derived. Second one, this one is base and this is derived class. Now we'll talk about how this referencing work in our upcoming lectures, but the idea that you need to remember here before I finish the class is that in a program, whenever we use function overriding, okay, child class replaces the parent class, number one. So child replaces the parent class. Number two, if you want to keep the parent class or call the functions of the parent class, what you can do, you can create the object in this way. So you can write parent class, then name a variable, and then you can call it as a reference of the child class. And whenever you write that x.display, it will call the function of the parent class. And here we have the example that is calling the function of the parent class, you see. So you still have the option to call the child class or the parent class, but now you have more control. And now this is only shown for one function. Sometimes it happens we have like 200 functions and we only want to replace 10. So in that case, what we do, okay, we just take the 100 functions and then we just overwrite 10 functions and the programs work just fine. So this is the main idea about function overriding.